A complex rational expression is a rational expression that has one or more rational expressions within its numerator or denominator. One method of simplifying a complex rational expression relies on multiplying by the least common denominator of all rational expressions within the complex rational expression. Let's see how we can do that. So we're going to look at the denominators. We have denominators in the numerator of 2 and 3, so our least common denominator needs to have a factor of 2 and 3. The denominator's denominator has 4, which we already have a 2, but we'll need another 2, and it has the 3, which we already have. Multiplying these together gives us a least common denominator of 12. Once we have the least common denominator of all denominators, we will now multiply the complex fraction by that quantity. And to maintain equality, we'll put a 12 over 12, which is equivalent to 1. Doing that, we will distribute 12 times each one of the terms in the numerator. So we have 12 times 1/2 minus 12 times 5/3. In the denominator, same, we'll use distributive, 12 times 3/4 plus 12 times 1/3. This integer has a denominator of 1, which is going to help with simplifying our fractions. Multiplying then, 12 over 2, or canceling out a 2, leaves us 6. We have a minus. 3 is a factor in 12 that goes in 4 times, so we have a 4 times 5, or 20. Moving to the denominator, common factor of 4 cancels out and is equivalent to 1, leaving a 3. 3 times 3 is 9. And our last one then, we have a 12 over 3 is another way of simplifying that to leave a 4. Doing the final simplification results in a negative 14 in the numerator and a 13 in the denominator for our no longer complex rational expression. Here we have a rational expression, and using that same technique, the denominator of each numerator and denominator has only one factor for a least common denominator of simply y minus 2. We're going to clear the complexity of this complex rational expression by multiplying by the special value of 1, which is that least common denominator over itself. This involves distributive property in the numerator and again distributive property in the denominator, which will result in y minus 2 times y plus y minus 2 times the rational number 1 over y minus 2. That takes care of the distributive in the numerator. The denominator, we have a y minus 2 times 1, which will be y minus 2, plus distributing it times the second term is a y minus 2 times the rational number there of 1 over y minus 2. Simplifying, we need to use distributive property again. Y times y is y squared. Y times 2 is 2y. Skipping over the addition and taking care of the multiplication, we have similar term over itself, which is equal to 1. 1 times 1 over 1 is 1. So there's our result in the numerator. The denominator, y minus 2 here. And if we jump over to the multiplication, we have again similar term over itself, which is equal to 1 over 1, which results in 1. In the numerator, we do have a trinomial that is factorable. It will factor into y minus 1 times y minus 1. The denominator, when we simplify, y minus 2 plus 1 simplifies into a y minus 1. And here we see we have a common factor over itself, which is equal to 1, leaving a final simplification to this complex rational expression of y minus 1. In this next example, we have a complex fraction using that same technique, the least common denominator of all the denominators. We need an a squared from the top. We have an a squared in the denominators, but we also have a factor of 2. So 2a squared is the least common denominator of all denominators. And using the technique that we have in the first two problems, we'll multiply by a special 1, which is 2a squared over 2a squared. We then will distribute that across all three terms in the numerator as well as in the denominator. We can simplify as we go if you become comfortable with that. 2a squared times 1 is 2a squared. When we multiply 2a squared times the minus 7a, an a will cancel out, leaving an a, and 2 times 7 for a 14a. Multiplying the third term distributively, the a squareds cancel out and leave a 2 times 12, and we'll put the product of 24. In the denominator, 2a squared times 1 is 2a squared. 2a squared times 1/2, the 2's cancel out, leaving just the a squared. And then multiplying the third term, the a squared cancels out, leaving the factors 2 and 20 to multiply to give us 40. Simplifying here, in the numerator we have a common factor of 2 between all three terms. We have an a squared minus 7a plus 12. In the denominator, combining like terms, we have two terms that have a squared in it. 3 plus 1, try it again, 2 plus 1 is 3a squared minus 40. Since the denominator has two terms and the largest common factor is 1 and it isn't a difference of squares, I can't factor it. So factoring the numerator isn't going to lead for any simplification. So we have our final answer. But if it needs to be in complete factored form, this trinomial does factor into a minus 4 times a minus 3 with that least or greatest common factor of 2 that we already had factored out over this prime polynomial in the denominator.